3 years ago, the United States cut China off from the one machine you supposedly cannot build an advanced computer chip without. It's called an EUV lithography scanner. It costs more than a passenger jet. Exactly one company on the entire planet knows how to make one, a Dutch firm called ASML. And in 2019, Washington made sure of a single thing: China would never get to buy it. The logic was simple: no EUV machine, no cutting-edge chips, cut off the machine, and you freeze an entire country's technology in place. That was the plan. So this past May, Huawei's chip chief, a woman named He Tingbo, the engineer Chinese media call the chip queen, walked onto a stage in front of the industry and said something that was never in the plan. Fine, we'll build the chip without the machine. And here is the part that should make you sit up. The phone in a Chinese teenager's pocket right now suggests she might be telling the truth. In the next few minutes, I'm going to show you exactly what Huawei claims it has built, the single number that made the entire semiconductor industry stop and stare, and the catch, the part nobody in Shenzhen wants to put on a slide. First, you have to understand why one machine matters this much. Making an advanced chip is basically printing. You print circuits onto a wafer of silicon, except the lines are thousands of times thinner than a human hair, and to print lines that small, you need light with an unimaginably short wavelength. That is what EUV does, extreme ultraviolet light. An EUV scanner fires a laser at droplets of molten tin 50,000 times a second to generate that light, then focuses it with mirrors so smooth that if you scaled one up to the size of Germany, the largest bump on its surface would be a fraction of a millimeter. It is arguably the most complex machine human beings have ever mass-produced, and ASML is the only company on Earth that makes it. So when the export controls landed, the message to China was blunt: the road to the leading edge runs through this one Dutch machine, and you are not allowed on the road. For most of the industry, that was game over. You cannot improvise your way around physics, or so everyone assumed. Except China didn't stop, it went sideways. There is an older, cheaper kind of machine called a DUV scanner, deep ultraviolet. China is still allowed to buy those, and it has been buying them by the crate. The catch is that DUV light has a longer wavelength, so it physically cannot print the finest lines in a single pass. So Chinese fabs do something clever and brutal. They print part of the pattern, shift the wafer a hair, print again, shift and print again, building one fine layer out of 4 overlapping exposures. The technique is called self-aligned quadruple patterning, or SAQP. It is slower. It is more expensive. Every extra pass is another chance to introduce a defect, but it works, and we know it works, because you can hold the result in your hand. Huawei's Kirin 9030 Pro, the processor inside its current flagship phone, was built by China's own foundry, smic, on roughly a 5nm class process, with no EUV anywhere in the production line. When analysts physically took one apart this year, the teardown suggested it was competitive with Intel's most advanced node, the one Intel calls 18A. Sit with that for a second. A country that was told it could never make a leading-edge chip without the forbidden machine is now shipping one, in volume, inside a phone you can buy today. But here's the thing: that shipping chip is already the old news. What He Tingbo announced in May is what genuinely turned heads. Her bet is this: if you can't shrink the transistors any further without EUV, then stop trying to win the shrinking game. Change the game entirely. The technique she unveiled is called LogicFolding, and the principle behind it she has named the Tau scaling law. For 60 years, chip making has chased exactly one number: how small can you make a feature, measured in nanometers. Smaller transistor, more of them, faster chip. LogicFolding says, forget going smaller, go up. Take the logic of a chip that normally sits flat on a single layer, and fold it. Stack it into 2 layers, so signals travel shorter distances, and you pack more computing into the same footprint. Huawei claims this delivers a 53.5% jump in transistor density at the very same process node. No EUV required, no smaller transistors required, just a smarter geometry. And if that number is real, it is roughly the equivalent of skipping an entire generation of chip making without buying a single new machine. And Huawei did not stop at one chip. He Tingbo put a date on the wall. By 2031, she said, this approach will let China deliver performance equivalent to a 1.4 nanometer chip. Now 1.4 nanometers is the bleeding edge of the entire planet. That is the node TSMC, the Taiwanese giant that manufactures the chips for Apple and for nvidia, plans to push into mass production around 2028. So Huawei is effectively saying, we will be 3 years behind the single most advanced chip maker on Earth. And I want you to notice how strange it is that 3 years behind is the brag. 3 years ago, the consensus was that sanctions would freeze China a full decade behind, permanently, with no path forward. Going from frozen forever to 3 years and closing, without the one machine everyone insisted was non-negotiable, is not a small story. It might be the story of the decade in technology, which is exactly why we now have to slow down and ask the harder question. Because here is what He Tingbo did not put on that slide. She announced a density number. She did not announce a yield. And in chip making, yield is everything. Yield is the percentage of chips on a wafer that come out actually working, instead of going straight into the bin. You can invent the most elegant architecture in the history of the field, but if only one chip in 5 survives the line, you cannot sell it at a profit. It is a science project, not a product. And the experts watching this were quick and careful to make that exact point. Paul Triolo, a veteran China technology analyst at the DGA Group, put it plainly. A folded design can absolutely produce real density gains, but that does not mean Huawei has solved the process, the yield, the power, the heat, and the device performance that true leading-edge manufacturing actually requires. Neil Shah, at Counterpoint Research, warned that the approach is still unproven at scale, and that stacking layers introduces brutal thermal and packaging problems, exactly the kind of problems that quietly destroy yields. And Lian Su, at the research firm Omdia, delivered the quietest and most damaging line of them all. Right now, there is nothing concrete that can be independently verified or benchmarked against anyone else. No outside auditor has confirmed that 53% figure. And the math underneath it is unforgiving. Reports put SMIC's pilot yields on 5nm class chips at somewhere around 20%. Now start stacking layers, and the odds multiply against you. Even if each individual layer came out at a healthy 90%, 2 layers together is 81%, 3 layers drops you to 73%, and that is before the heat and the packaging complexity take their own cut. So, is this a genuine breakthrough, or is it a very confident brochure? The honest answer, today, is that we do not know yet, and anyone telling you they are certain either way is selling something. But here is where it gets genuinely interesting. Even the skeptics aren't laughing. And there is a reason for that. The sanctions were designed to remove China's options. What they actually did was remove China's distractions. When you are allowed to buy the EUV machine, you throw money at the machine, just like everyone else, because that is the obvious move. When you can't, you are forced to ask a completely different question. Is there another axis to compete on at all? LogicFolding is an attempt at that other axis. It may never hit 1.4 nanometers by 2031. It may slip, it may disappoint, the yields may simply never arrive. But the mere fact that Huawei is now competing on architecture and geometry, instead of on raw transistor size, means the wall the United States built did not stop the climb, it just turned the climb sideways. And the strategic backdrop makes that matter even more. Nvidia, the most valuable chip company on the planet, has been steadily squeezed out of the Chinese market by this same export war, to the point that analysts at the Brookings Institution now describe the United States as effectively out of the AI chip market in China altogether. And that is the pattern. Every door Washington closes hands the room to a domestic Chinese champion that grows up to fill it, which is the irony sitting underneath this entire story. The ban was meant to keep China dependent. Instead, it may have helped fund the exact independence it was built to prevent. So where does that leave us? With a chip that is genuinely shipping, a number that is genuinely unverified, and a roadmap that is either the next great leap in computing or the most expensive slide deck in Shenzhen. We will know which one inside of about 2 years, and here is the tell to watch. Track SMIC's yield announcements, not Huawei's density claims, because yield is where the truth lives, and it leaves a much bigger question, one I am going to dig into in the next video. If China really can route around the most advanced machine on Earth, then what exactly were the export controls protecting, and who did they end up protecting it from? That answer has a number attached to it even bigger than 53%. If you want it the day it's ready, subscribe. This channel breaks down the China technology and economy stories that are quietly reshaping the world, packaged sharp, delivered straight, no hype and no spin. I'm Sino Surge. I'll see you in the next one.